Okay, today we're going to learn about another method of solving the quadratics called completing the square. It's pretty easy once you get started with it. So, let's go. Okay, so let's take this equation, x squared minus 6x minus 4. Now, our very first step in here is going to be to isolate the constant. That's the 4 that we're going to isolate on the side. Okay, now once we get the 4, or whatever the constant is, to the other side, then we're going to take a look at completing the square. We're going to do this by starting with that 6 that's underlined. And we're going to take half of that, half the middle term. We're going to take half the middle term and we're going to square it. And when we get that, we're going to square it. We're going to get 9, and we're going to add it to both sides. Now what we have done is we have completed the square on this side, on the left-hand side of the equation. What that becomes is x minus 3 squared. We have completed the square by making a perfect square on the left side. Then we add the right side of the equation, giving us 13. Then we solve this like we've been doing in class, which is take the square root of both sides. We get x minus 3 on the left, and we get square root of 13 on the right-hand side of the equation. Remember, we put plus or minus. Once that's solved, we're going to get x equals, and we bring 3 to the other side, and 3 plus or minus the square root of 13, and that is our final answer. So here's another example, x squared minus 3x plus 5. Now in this example, the first thing we have to do is isolate that constant. So that means that we're going to rewrite the equation, leaving a blank space, and then bringing the 5 over to the right-hand side, making it negative 5. We take half the middle term. The middle term is 3. So we notice when we take half the middle term, we divide by 2 or multiply by a half, square that term, which gives us 9/4, and we put it in the blank space. We also have to add it to the other side of the equation. Now, once we do that, we have a complete, perfect square on the left-hand side. Remember, we take the number that we use to get our perfect square, and that's the number that goes inside the parentheses. So we get x minus 3/2 equals, and on the right-hand side of the equation, we're going to change that 5 to 20 over 4 so that we can add it to 9 over 4, get a common denominator. That cancels out, giving us 11 over 4, negative 11 over 4. Then what we do is we take the square root of both sides. We get x minus 3/2 on the left, and on the right we get plus or minus. Now we're going to take the square root of the 4 on the bottom, which gives us 1/2, because the square root of 1/4 is 1/2. I comes from the square root of the negative, and then finally we have 11 left over. This provides us with the answer, which leaves us with our solution of x equals positive 3/2, because you bring it over to the other side, plus or minus I square roots 11. 1/2 I square roots 11. Got about the 1/2. So, okay, so here's another example. Excuse me. We're going to get 2x squared minus 7x plus 12. I'm going to isolate the constant as before. But we notice this time, let's look back, we notice this time that there's a 2 as the leading coefficient. And this is one little thing that's very, very important for you to remember, is that you can't use completing the square unless the leading coefficient here is 1. So we have to divide both sides of the equation by 2 in order to get that. So And when we divide by 2, we get 7 halves x, because we divide 7 by 2, equals negative 12 divided by 2 gives us negative 6. Now, I know how much you hate fractions, but we still have to take half of the middle term. This middle term we have to take half of. So, how do you take half of one that's already a fraction? Well, let's look here on the side. We'll take 7 halves, but instead of dividing by 2, we're going to multiply by a half. And that's going to make it much easier for us to get half of 7 halves, which would be 7/4. And then we're going to square 7/4, which gives us 49 over 16. And we got this by squaring 7/4. We are then going to add 49 over 16 to both sides. Whoop. Jump back. So we're going to add 49/16 to both sides. So, looking at it from this standpoint, okay, we have a perfect square on the left-hand side, which gives us x minus 7/4 half. And then, of course, we have to get rid of that negative 6, and we're going to turn that negative 6 into negative 96 over 16, because that is negative 6. Leaving us negative 47 over 16. Then we square root both sides, and we get x minus 7/4 equals, and then we have plus or minus 1/4, because we are taking the square root of that 16, but the 16 is in the denominator, hence why we got the 1/4. And then we have I, and then square root of 47. 47 is a prime number, so we can't divide that up anymore. The I comes from the square root of the negative value that's right here. So then we add 7/4 to both sides, giving us x equals 7/4 plus or minus 1/4 of I, square root of 47. Now, if you want to clean it up a little bit, we can get the one common denominator under all of the numerator of 7 plus 1. That comes from right here. 7 plus 1 I, square root of 47, all over 4. So that completes our completing the square. And hopefully, if you have any questions, you can ask me in class. But I think this is pretty easy once you get the hang of it. Good luck.